plasma calcium. There are three forms of plasma calcium. Free or ionized calcium, that is 50%. Protein bound calcium, that is 45%. Mainly albumin bound. And soluble calcium complexed with anions. Which anions? For example, citrate, phosphate, that is 5%. So there are three forms of calcium that remains in the plasma. Free or ionized calcium, which is 50%. Protein, mainly albumin bound calcium, 45%. And soluble calcium complexed with anions. For example, citrate, phosphate, that is 5%. So total 100%. And these three forms are together called plasma calcium pole. All these three forms of plasma calcium are in equilibrium with each other and together represent the plasma calcium pole. These three forms remains in the plasma in equilibrium state, and these three forms are together called plasma calcium pole. Among these three forms, free calcium or ionized calcium is 50%, and this calcium is biologically active and it determines our body calcium status, and this calcium is hormonally controlled. Among these three forms of plasma calcium, only free calcium is biologically active, and it has the main function in our plasma, and this calcium is hormonally controlled and it determines the body calcium status. Now, what are the normal value or reference range of plasma calcium concentration? This is another very, very important question for your Viva. Total plasma calcium concentration in milligram per percent or milligram per deciliter unit, 9 to 11. In millimole per liter unit, 2.2 to 2.6. And in milliequivalent per liter unit, 4.8. You have to remember all the units and all the values. Total plasma calcium concentration, 9 to 11 milligram per deciliter or milligram percent. As the free calcium or ionic calcium is 50% of total calcium. So the values are, the values are 50% less from this total value. Free calcium is 5%, 5 milligram per deciliter. And in millimole per liter, 1.2. In milliequivalent per liter, 2.4. Just half the value of total calcium, as free calcium is the 50% of total calcium. Understand, students?
Yes, ma'am.
So you have to remember the both value very well. If you remember the one value, you can easily tell the value of other free calcium, because these values are 50% less than from this. Now, what are the functions of plasma calcium? What are the functions of calcium? তোমরা সবাই জানো ক্যালসিয়ামের ফাংশন কি? It helps in bone mineralization. It also helps in blood coagulation, as calcium is one of the component of clotting factor. It acts as intracellular second messenger in transmembrane signaling, and it helps in the release of hormones, for example, insulin, parathyroid hormone, activation of enzyme and cell growth. It has also some function on neuromuscular activity. For example, muscle contraction, control of neuromuscular excitability, and release of neurotransmitters. Control of neuromuscular excitability. What does it mean? In hypocalcemic state, there is increased excitability, and in hypercalcemia, it causes CNS depression. So calcium acts as neurosedative. Now calcium balance. Total intake of calcium is 1000 milligram per deciliter. What are the sources? Milk and milk products, fish, meat, vegetables, etc. And total output also same, 1000 milligram per day, mainly through feces, that is 800 milligram per day, and through urine 200 milligram per day. So intake and output same, 1000 milligram per day, and output is through two routes, feces 800 and through urine 200 milligram per day. So calcium balance may be positive, equilibrium, and negative. When intake is more than loss, that is called positive calcium balance, and it occurs in childhood during growth. And when intake is equal to loss, that is calcium equilibrium, it occurs in adult life. And when loss is more than intake, calcium intake, that is called negative calcium balance. It occurs in elderly person and also in post-menopausal women. So positive calcium balance occurs in childhood during growth. Calcium equilibrium occurs in adult life, and negative calcium balance occurs in elderly and in post-menopausal women. In negative calcium balance, see, calcium loss is more than calcium intake. Now, regulation of calcium balance or regulation of plasma calcium concentration. Very important question for your written and also for Viva. Very important. How serum calcium level is maintained or how calcium concentration is regulated. Very important question. Calcium is regulated in our body by two defense mechanisms. One is first line defense, another is second line defense. And first line defense is done by calcium buffer activity of labile calcium pole of bone. That is, first line defense occurs by labile calcium pole, and second line defense is occurred by hormones. This is also called hormonal regulation. So calcium balance is regulated by first line defense mechanism and second line defense mechanism. And first line defense mechanism is called by is done by labile calcium pole of bone, and second line defense is done by hormones. First line defense, it is done by calcium buffer activity of labile calcium pole of bone, because all of you know labile calcium is loosely bound to bones and it is readily exchangeable and remains in reversible equilibrium with ECF calcium or serum calcium. So in hypercalcemic state, hyper means more and calcemia means calcium concentration in blood. When increased calcium concentration in blood, then calcium from the plasma immediately deposit in the labile calcium pole of bone. And in hypocalcemic state, that means when serum calcium level is low, at that time calcium from labile calcium pole of bone immediately releases to plasma to maintain the serum calcium level normal. Now second line defense, which is done by 3 hormones and done by 3 organs. 3 hormones are calcitriol or 125 dihydroxycholecalciferol, parathyroid hormone, and calcitonin. 3 hormones. Calcitriol, parathyroid hormone, and calcitonin. Calcitriol is the active form of vitamin D. The another name of calcitriol is 125 dihydroxycholecalciferol. And it is also done by, and these 3 hormone acts on 3 organs. What are they? Intestine, bones, and kidney. So second line defense is done by 3 hormone and 3 organ. 3 hormones are calcitriol, parathyroid hormone, and calcitonin, and 3 organs are intestine, bones, and kidney. Now, how this hormone regulates blood calcium? Calcitriol which is the active form of vitamin D, and another name of calcitriol is 1,25-dihydroxycholecalciferol. This calcitriol synthesis is stimulated by hypocalcemia, hypophosphatemia, and parathyroid hormone. What does it mean? Hypocalcemia means decreased calcium concentration in blood. Hypophosphatemia means decreased phosphate concentration in blood. And PTH means parathyroid hormone. When our body calcium, phosphate, and blood calcium, phosphate, and parathyroid hormone, when our serum calcium and phosphate decrease, they stimulate calcitriol synthesis. And parathyroid hormone itself also stimulates calcitriol synthesis. Now what happens? Calcitriol increases intestinal absorption of calcium and phosphate. This calcitriol has function on intestine, bones, and kidney. How? On intestine, they increase intestinal absorption of calcium and phosphate. On bones, they facilitate parathyroid hormone-induced bone resorption and release of calcium and phosphate. And on kidney, it facilitates parathyroid hormone-induced calcium reabsorption from distal nephron. See, calcitriol helps in intestinal absorption and also helps in calcium reabsorption from distal nephron. So the ultimate net effect of calcitriol is increased plasma calcium and phosphate level. And how they increase plasma calcium and phosphate level? By these three mechanisms. At first, they act on intestine and increases intestinal absorption of calcium and phosphate, acts on bone and facilitate parathyroid hormone-induced bone resorption. And after bone resorption, there are calcium and phosphate are releases, and acts on kidney to facilitate parathyroid hormone-induced calcium reabsorption from distal nephron. By this three way, they ultimately increases
the lower end of the adductor canal jump at the junction of the
কিছু বলতেছো কেউ স্টুডেন্ট? আমার কথা কি শোনা যাচ্ছে?
জি ম্যাম, শোনা যায়।
বোঝা গেছে ক্যালসিট্রাইল কিভাবে কাজ করে? হাউ ক্যালসিয়াম অ্যাক্টস or how calcitriol controls serum calcium and phosphate level?
Yes, ma'am.
By three way. Increase intestinal absorption of calcium and phosphate, facilitate parathyroid hormone-induced bone resorption and release of calcium and phosphate, and on kidney, facilitate parathyroid hormone-induced calcium reabsorption from distal nephron. And by this three way, they ultimately increases plasma calcium and phosphate level. Now parathyroid hormone. Parathyroid hormone secretion is stimulated by hypocalcemia and hyperphosphatemia. Hypocalcemia means decreased serum calcium concentration, and hyperphosphatemia means increased phosphate concentration in blood. In these two states, parathyroid hormone secretion stimulated. And parathyroid hormone how acts? At first, it acts on bones and it increases bone resorption and release of calcium and phosphate. It increases calcium reabsorption from distal nephron. It inhibits phosphate reabsorption from proximal convoluted tubule to increase renal phosphate excretion. And parathyroid hormone stimulates calcitriol synthesis to increase intestinal absorption of calcium and phosphate. So ultimate effect of parathyroid hormone is increased calcium and decreased phosphate level in the blood. Another hormone is calcitonin. Calcitonin is produced by parafollicular cells of thyroid gland in response to hypercalcemia, and it protects against hypercalcemia by bone mineralization and inhibition of bone resorption, and it acts on kidney and increases renal excretion of calcium and phosphate. So the net effect is decreased plasma calcium and phosphate level.